Hello everyone, welcome to the new tutorial, which is basically the single pass rolling of a thick plate. Now we start by renaming the model one, and we can rename it as Explicit. Press on OK. In the model tree, double click on parts and name this as plate. Over here, modeling space is 2D, and other than that, we can keep it the approximate size as 0.5 and press on OK. Continue. So over here in the sketching domain, we choose the rectangle option and arbitrarily create a rectangle. Now we can do the dimension. So this dimension should be 0.02, whereas this dimension is 0.092. Now press on done, and this is the first part, the plate. Now we create another part and name this as roller. Again, the modeling space is 2D, and now we select the analytical rigid type over here, and approximate size is 2. Press on continue. So now what we want to do is we want to use the create arc tool and sketch a 90-degree arc of arbitrary radius. So we can choose this as the center point, and this can be the starting point of the arc, and this can be the ending point. So now we can dimension this arc, and we want to have a radius of 0.17. Right, now press on escape and done, and so this is the arc that we want. Now let's go on to put the reference point. Go on to tools, reference point, and this is our reference point, which is basically the center of the arc. Next, let's create a material. Double click on the material over here and name it as steel. The density is 17850. Now put the Young's modulus over here as 1.5 e to the power 11 and Poisson's ratio as 0.3. Now what we want to do is we want to put in the yield stress at different strain values, and to do that, again go on to the mechanical and plastic option. Over here we'll put in 11 values of stress and 11 corresponding values of strain. I have these values written typed already, so I can press on Ctrl V. Similarly for the strain values as well. So these are the stress and the strain values. Now we can press on OK. Going on to sections, we create a section, name it as plate section, and it's a homogeneous solid section, and press on continue. Keep the thickness on, press on OK. Now over here we need to expand the plate option, plate tab, and put in the section. Press on done. Yeah, so okay, and the plate section has been assigned. Next, moving on to the assembly module, create an instance, and over here we select both the parts. Press on OK. So now what we want to do is we want to go to the tools option over here, choose datum, and enter parameter. Choose this and put as 0.2. Now we'll translate instance, and this is the instance that is to be translated. Press on done, choose this as the starting point and this point as the end point. Press on OK and done. Now let's create four sets, sorry. So double click on sets, and the first set is named as left, and so choose this edge, press on done. Next is the bottom set, press on continue and choose this edge. Okay. Now we create the plate set, press on the entire plate, done. The last set that we create is the reference point, press on continue and choose this reference point, done. So now we have created four sets. Now let's double click on surfaces, and in this dialog box we need to create actually two surfaces. So the first one is the roller, press continue and select on the roller, done, and we choose this magenta one, which is towards the plate. So let's create another surface as well and name this as top plate, continue, and basically select this edge and this edge as well, press on done. So now we have to create a step, and double click on that and name this as single pass rolling, and choose dynamic explicit as the type, press on continue. In this dialog box we put the time period as 0.1, and in the mass scaling option we use the use scaling definitions below, press on create. Over here we enter the scale factor as 1600, and we choose the region as set, and over here we choose the plate and press on OK. That's all that we need to do, and over here as well press on OK. So now we accept the default field output request, but in the history output request we right click and press on edit, and over here we select the domain as set and over here as the reference point, and we put the interval as 100, and from the list of available output variables in the forces and reaction, and we press on this as well, we need to choose RM3, press on OK. Now we go on to the other in the main menu bar and choose this ALE adaptive mesh domain and press on edit. In this dialog box we use the ALE adaptive mesh domain below, and keep the remeshing sweeps per increment as 3. We need to select the region as well and press on edit and go on to the sets and select the plate over here, continue, and we toggle this on as well. We need to go on to the create adaptive mesh controls as well, and over here we create we go press on continue, and don't change anything in this dialog box, just press on OK and press on OK. Now we need to do the surface to surface contact, And to do that, we double click on interaction properties. In this dialog box, we name this as friction and press on continue. This dialog box appears, and over here we go on to the tangential behavior, choose penalty, and the friction coefficient as 0.4, and press on OK. Now we go on to the interactions, double click on this, and in this dialog box, uh, we can name, we can actually keep the same name and choose surface to surface contact explicit option and press on continue. And over here in this dialog box, firstly we select the ruler over here and press on continue, and choose the second surface type as surface again and choose top plate. Press on continue. In this dialog box, we don't change anything and press on OK. Now we need to create three different boundary conditions, and to do that, we right click on boundary conditions and go on to the manager. And over here, what we do is we press on create and create the first boundary condition as bottom, and the step is initial, and choose displacement slash rotation as a step. Press on continue, and over here choose bottom and put toggle on the U2. Press on OK. Now let's create another boundary condition and name it as fixed roll. Step is again displacement rotation. Continue and choose the reference point over here. Continue and toggle on U2 and U1. Press on OK. And the last boundary condition is rotate roll, and the selected step is velocity, angular velocity, and the step is single pass rolling. Press on continue and again choose the reference point. And in this dialog box, toggle on the VI3 and put the value as 6.2832 and press on OK. Press on dismiss, and to put on the initial conditions, we double click on predefined fields, and over here we choose the step as initial, and category is mechanical, and the type of step is velocity. Let's name it as initial velocity. Press on continue, and in this dialog box choose the plate and press on continue. This dialog box appears, and over here let's just put the value of v1 as 1.01587. Press on OK. And now we move on to the meshing, and to do that, go on to the parts module, and over here under the part plate table tab, double click on mesh, and let's select the mesh type, mesh element type. Press on done. Over here we choose the element library as explicit, and over here we choose the family as plain strain, and that's all that we need to do over here, and press on OK. And now to seed the part, let's put the approximate global size as 0.002. Press on apply and OK. And lastly, we go on to the mesh controls, and over here choose the algorithm as medial axis and the element shape as quad. Press on OK. Go on to the mesh the part, and the mesh has been completed. Now let's save the file before creating a job. press on OK, and create a job, submit it, and wait for it to complete. So now, since the job has been completed, this is the results tab where we can see the misses stress, and basically after pressing on this button we got these. So uh, this is the undeformed shape, and this is the misses stress. And so what we can basically do is we can go onto the view tab, and over here if we select the ODB display options, in this dialog box we can increase the refinement level to extra fine, and next we can uh, click the sweep extrude tab, and over here we can toggle on the extrude elements, and if the depth is not already 0.01, make it 0.01, and similarly we toggle this on as well and choose specify and keep the depth as 0.01 and press on OK. Now you see this is what you get. Now since the uh, explicit analysis has been complete, we move on to the implicit analysis. So basically we copy the model and name it as implicit, press on OK. Now we need to replace the step with a static general step. So over here what we can do is we can replace this step and choose a static general step and press on continue. Over here let's keep everything as normal and press on OK. Next, from the main menu bar, select other, and this one option, adaptive mesh domain, edit and single pass rolling. uh, in this dialog box we choose on no ALE adaptive mesh domain for this step. uh, that's all over here. Press on OK. You can actually rename this step as well, and let's rename as establish contact. Press on OK, and let's edit it. So the maximum number of increments are 100. The initial increment size can be put as 0.0001, and the minimum increment size rather than power -5, it's -8, and maximum is 0.001. And over here the total time period rather than 1 is 0.001 seconds, and turn on the nonlinear geometry and press on OK. Create another step and name this step as roll pass. Choose a static journal. So in this dialog box the total time period is 0.099, and in the incrementation maximum number of incrementations are 500, and initial is 0.0001, minimum is 9.9 e to power -7, and this is the maximum. So press on OK. Now from the main menu bar select output, and over here restart request. In this dialog box let's specify a restart frequency, and to do that we can put it as 250 for both the steps. So here we edit the field output request, and in this dialog box change the interval as 25 rather than 20, and press on OK. Now select others from the main menu bar, and over here general solution controls, and over here we choose the edit and roll pass. So this dialog box appears over here, and to choose the specify option, and in the time incrementation tab we toggle on the discontinuity analysis, and press on OK. Now double click on boundary conditions to create the boundary condition. So we can actually uh, name the boundary condition as feed piece, and the step as establish contact, and over here we can choose the velocity angular velocity, and if we go on to the uh, region by going on to the steps, choose the left, continue, and over here we put the value of v1 as 1.01587. Press on OK. So now in the model tree, we select the manager on the boundary conditions option, a tab, and we select the feed piece boundary condition over here and deactivate this and press on dismiss. So now we have to do the meshing. So over here we expand the part and the plate over here, double click on mesh. So uh, we go on to the mesh element type, select the part, press on done. Over here uh, we choose the element library as standard and press on OK. Let's save the model again and create a job and wait for the job to complete. So this is basically the Mrs. Stress, and so this is the Mrs. Stress on the undeformed shape, and if you want, we can plot the contours on deformed shape as well. So you just see the difference over here in the implicit solution. So one thing that we can do is we can actually uh, divide the viewport into two viewports and side by side have a view of the implicit and the explicit solution. So at the moment, this is the explicit implicit solution. So what we can do is viewport and press on create. Now we go back and we actually uh, go on to the results of the first job, which is the explicit one. And now press on deform, and when we go back on viewport and press on tile horizontally, you can see over here that over here the job one, which is basically the explicit one, and this is the implicit one. So this one is the explicit solution, this is the implicit solution, and you can see the difference in the stress values as well. So this is what you can do. You can change the view as you want. Similarly for this, so to the output databases, and from here in the history output you can choose the history output, and at the moment we have only selected the reaction moment 3. So if we want to plot this, we press on plot. So this is the RM3 for the implicit for the explicit solution, and similarly if you want to do for the implicit solution as well, we go on to the history output, and over here if we choose this and plot, you can see this for the implicit solution. So this brings us to the end of this tutorial.